Hey guys, it's Mr. Gibson here. I'm going to show you guys how to solve multi-step equations. The first thing we're going to do here is we're going to solve one-step equations to get the general idea of how to solve all types of equations. First of all, anytime you're trying to isolate a variable, so in this case an x right here, we have x plus 3 equals 8. If we're isolating this variable, we want to get rid of this number on this side. So we want to get rid of the plus 3. You're going to use the opposite operation. So the opposite operation of plus 3 is going to be minus 3. So x plus 3 minus 3 is x plus 0, which is just x. 8 minus 3 is 5, so that's how you get the answer, x equals 5. Again, opposite operation. Here we have x minus 4 equals 10. Well, x minus 4, the opposite operation of minus is plus, so we'll have plus 4. X minus 4 plus 4 is x plus 0, which is just x. 10 plus 4 is 14, so that's how we end up with x equals 14. Next, we have 3x equals 9. Again, this is 3 times x, 3 times a variable. So the opposite operation, division. So in this case, we're going to divide 3 on both sides. 3x divided by 3, well 3 divided by 3 is 1, so that's 1x or just x. 9 divided by 3 is 3, so that's how we get x equals 3. Finally, we have x over 5 equals 10. Well, in this case, the x is being divided by 5, so the opposite operation is multiplication. So that means we're going to multiply 5 on both sides. Okay. So in this case, this will be 5 over 5, which is 1. So that's 1x. 1x is the same thing as x. 10 times 5 is 50. Okay, so this were all one-step equations, highlighting that you use the opposite operation to isolate the variable. So let's move on to some actual multi-step equations. Okay, so here I have 3x minus 4 equals 8. So again, I'm going to add 4 on both sides. Okay. 3x minus 4 plus 4 is 3x. 8 plus 4 is 12. Well, the variable is not entirely isolated at this point. We still have the 3 times x. Again, multiplication, so we're going to use division. So I'm going to divide 3 on both sides. 3 divided by 3 is 1, so that's 1x or x. 12 divided by 3 is 4. Okay, so that's how we end up with x equals 4. Next problem here, I have negative 2x plus 2 over 3. The whole thing is over 3 equals 6. The first thing I want to do is get rid of this dividing 3, so we're going to multiply 3, again, opposite operation. That means 3 over 3 is 1. So those, I'll use the terminology here, cancel out now, okay? Sometimes we even draw a little line to indicate that 3 over 3 is 1, so I can ignore that 3 now. 6 times 3 is 18. Again, we're down to a few more steps here. This point, I have this plus 2, so I'm going to go ahead and opposite operation minus 2 on both sides. Okay. So plus 2 minus 2 is 0. Those, again, basically cancel out. 18 minus 2 is 16. Okay, so I have negative 2x equals 16. Opposite operation of multiplication, because it's negative 2 times x, is division. So I'm actually going to divide negative 2 on both sides. Okay, the negative 2 and the negative 2 cancel out, as we are now saying, and I get the variable x there. Notice 16 divided by negative 2, well, that's not just going to be 8, it's going to be negative 8. Okay, so times a negative or divided by a negative, a positive divided by a negative will be a negative. Alright, so I'm going to show you guys a few special cases now. This will be a longer video than we're going to be used to this year. So in this case right here, I see a lot of kids, I call this the no distribution needed. So I have this 5, so 5 times x plus 2 equals 15. So we have the parentheses. We could distribute this 5. We could. However, sometimes when you have a case like this, it's easier just to go ahead, since you're timesing 5 by everything, just divide 5 on both sides, okay? Divide whatever number's in front of here. Sometimes that makes it easier. Again, the 5's cancel out, and I'm left with, because 5 over 5 is 1, I'm left with x plus 2 on the left side. 15 divided by 5 is 3. Now it's just a one-step equation, opposite operation, plus 2 is minus 2 on both sides. Our answer is x equals 1. Okay, so that's the first special case. No distribution needed. You can make these types of problems a little easier because you don't have to do all those distribution steps. A few other special cases here. Variable on the right side. Okay, so instead of having the x on the left side, the x is on the right side. I have 9 equals 3x. Okay, what I like to do, don't have to do this, okay, it is a perfectly legal move to just go ahead and switch the sides, okay? It makes no difference that it's 9 equals x times 3 or 3x equals 9. It does not matter. So I go ahead and switch it because I like to get it to where I'm used to seeing it. So 3 times x equals 9. That means I'm going to divide the 3 on both sides, okay? 3 over 3 is 1, so that's 1x or x. 9 divided by 3 is 3. Next thing is variables on both sides. So what I like to do, again, I like to put the variable on the left side and just not worry about it, okay? There's more than one way to do this, but here's what I do. I'm going to send the variables to the left. So what I mean by that is I'm going to go ahead, this variable is 3x, so again, this problem is x plus 2 equals 3x plus 5. I'm going to take this 3x, I'm going to subtract the 3x on both sides. Okay? 3x minus 3x, that's 0. So that cancels out my x's on the right side. I'm just left with this 5 right here, okay? Now, like terms, that's all we're going to add on the left side. X and 3x are like terms. So x minus 3x, negative 2x, okay? Negative 2x, because that's 1x minus 3x. 1 minus 3 is negative 2. So that leaves me with negative 2x minus 2 equals 5. Well, now this is just a two-step equation. We're pretty used to this. Going to subtract the 2 on both sides, opposite operations. The 2's cancel right there. 5 minus 2 is, I made a quick mistake right here. Let me fix this. 5 minus 2 is 3. Okay, it's 3, okay? We all make mistakes. There's a proof right there at the start of the school year. Negative 2x equals 3, so I'm going to divide negative 2 on both sides. Okay? And that leaves my answer as not this right here, but x equals negative 3 halves, okay? Negative 3 halves. And here's the thing, in high school, I like to see the fraction, even if it's an improper fraction. I like improper fractions the best. They tell me the most information. We can have discussions about that this year. All right, thanks for your attention.